Hello. In this session, we are going to understand the technology stack of IoT. You could have heard about the OSI layer, and we are going to connect it to OSI layer for the learning approach. If you know open system interconnection layers, physical, data link, network, transport, session, presentation, and application layers, it would be easy for you to understand the same thing here but in a different way. We are going to learn about the technology stack completely. After listening to this session, you will understand the layers in the technology stack of IoT, why is this classification needed, and importance of each layer. Let's learn the stack. There are 7 layers, that's why I said that we can connect it to OSI layers. The layer 1 is all about sensory layers. Layer 2 is for microcontrollers. Layer 3 is for wired interface. Layer 4 is radio frequency layer. Layer 5 is message layer. Layer 6 user interface layer. And finally, followed by application layer. It's very easy to understand why do we need all these layers, but with an example. Layer 1 is called sensor layers. What is sensors? We are talking always about sensors, and it is tough to digest the term sensors without understanding it with a proper example. Let's relate the human organs to sensors. It is very easy then to understand how exactly these sensors work. Ears of you can be related to the vibration or sound sensor. Eyes can be related to the color sensor or the camera. Nose is obviously the odor sensor. Skin can be related to piezo plates or FSR sensors. And now it is very easy for you to understand that we have got a lot of sensors in our body. Similarly, any IoT application will be built with some sensors. The way you choose sensors is basically based on the application that you are building. These sensors are the fundamental organs for building any IoT applications. And remember, choosing the appropriate sensor is the real tough thing that one should go ahead with. The second layer is called microcontrollers layer. The microcontroller is like heart for the human body. Although the sensors fetch the required data, it is mere waste without having processing unit for analyzing the data. Well, you acquire the data, I need to analyze the data. Without understanding the data after analysis, it is not at all useful for fetching the data, putting so much of effort. There are so many sophisticated modern microcontrollers available in market today, ranging from few hundreds of rupees to few dollars, which is very expensive as well. I have got microcontroller only for processing, which is like Arduino Uno. I have got microcontroller with Wi-Fi support, which is beautiful connectivity for prototyping and proof of concept understanding. Node MCU is the best example. Controllers with Wi-Fi and Ethernet port are also available in the market, which include Intel's UP Squared kit, Raspberry Pi kit, BeagleBone kit, etc. But this might be little expensive. It could be ranging around $300 if you go for UP Squared kit. It would be ranging around few hundreds of rupees if you go with Arduino or Node MCU. This is what I told you. Choosing the microcontroller is also equally important. Whichever microcontroller you need to choose is based on the application that you are developing, and definitely you should choose the most appropriate one based on the cost, power, and other constraints as well. Layer 3, wired interface. Well, first point is we have to choose the sensors. Second point, we have to choose the microcontroller. Now, we have the sensors connected to the microcontroller. But how do we code it and make it work as we need? Wired interface layer helps us in interfacing the physical devices and microcontrollers. It helps in the data transfer between the physical device and firmware of the microcontroller. Let me give you a simple example. We are coding to make the microcontroller understand that it is going to fetch data from a temperature sensor. That code has to be burnt into the microcontroller, and that has to be done appropriately with a cable from the laptop. You will connect the laptop to the microcontroller and the microcontroller to the sensor. This interface is what we are talking as wired interface. Some common examples which can be cited right now are the connection between laptop and Arduino using USB-B cable. EAT commands data transfer between the laptop and GSM module using RS-232 cable is another example. We are going to see a lot of these kind of examples in near future while we are building the product. There you will understand it much better. The fourth layer is called radio frequency layer. Though the microcontrollers that we have referred some time back are sophisticated and are very rich in features, they still lack something. What is that? That is memory. The modern microcontrollers, whatever we have seen, including Node MCU or Arduino, they do not have sufficient memory. They have memory mostly in order of KBs. Some microcontrollers like Intel's UP squared has got memory in terms of GB, but it would not be even sufficient when you acquire data continuously, streaming data continuously from the sensor. So we will have to store the data onto the cloud most of the time like Firebase or Adafruit. This RF layer will enable us to transfer the data between the physical devices and the cloud. Sending the sensor data from Node MCU to Adafruit or Firebase through Wi-Fi is a simple common example that we can cite right now. We are going to present you an example at the end of this session which is going to be helpful in making you understanding the complete flow with ease. The fifth layer is message layer. We have chosen the sensor, we have chosen the microcontroller, we have interfaced properly, we have chosen the right RF mechanism as well. Now, what is the next step? We have established the connectivity between the physical devices and the cloud using RF layer. But what about the data transmission? The message layer will ensure that the data is all transmitted smooth. A simple example that I can cite right now is Facebook chat. I am chatting with somebody, but that somebody has left because of some reasons. Whatever chat I have presented here, whatever content I have presented here will reach him in the same order. There will not be any mismatch in the order of the content that I have typed. MQTT is one of the protocols that we are going to use, which will help us in sending the content as it has to be sent. MQTT is Message Queue Telemetry Transport. We are going to implement this in near future with some examples as well. This is one of the common examples that we can cite towards understanding the usage of message layer. The sixth layer is called user interface. We have all the data, we have all the processing, but where do we visualize it? The user interface layer helps you to build mobile or web applications that can be utilized by the end user to visualize the process data. Nowadays, most of the products come along with the Android app, and one simple example that I can cite here is all the smart bands that are being sold in the market are always supported by a mobile app, which will show you the complete visualization, which include the heartbeat, the movement, the calories burnt, etc., which is nothing but the data. The data, when presented as numbers, will not have any sense. The data, when presented as an appealing chart, will have much more sense for the end user. That is what the user interface is all about. The application layer is the one which is the last layer that we are going to discuss. What are we going to do with all the available previous 6 layers is what is called application layer. You need to build an application like smart vegetable quality monitoring, smart roads, smart parking, and this is what is called application. We are going to present a simple example here that we have built with the sensors right from layer 1 to layer 7 we have utilized. We have built a system for perishable quality monitoring during the transport, and that will be explained very clearly in the demo that I'm going to show you right now. We have used sensors that will acquire data. The data is nothing but the quality data about the vegetables and fruits. That data has to be sent to the cloud, and we are using Wi-Fi, that is nothing but the RF layer. We have used MQTT to make sure that the data is all going as it has to go. We have developed an Android app to see what has happened. And finally, this application is called Smart Perishable Quality Monitoring. This is a very simple app which is developed by us to prove you the concept of the entire IoT stack with ease. Here you can see that I have got the complete system set up along with the vegetables. We are going to monitor the quality of the vegetables real time. Here we have certain vegetables available, out of which we have purposefully kept some vegetables which are rotten. This is rotten, this is rotten, this is semi-rotten. Now we have got sensors here. This sensor will be capable of measuring the temperature as well as humidity, and this sensor will get the odor. So once the data is obtained, it will be transferred to the microcontroller which is here. My pencil is marking you that now. This microcontroller will collect all the data and it will be ported onto the cloud. So once the data is onto the cloud, you can see that the data is getting recorded consistently real time. So once the data is recorded in the cloud, the analytics will be made and the decision can be arrived, as in which box has to be delivered at which place. Now I'm opening my app which we have designed, and you can say that after some point in time you will get the grade for each box. Here the first box which we have has got the grade C, which means that it is having poor quality, which means that it has to be delivered at the earliest. Now where to deliver it will be the point now we need to address. Click address and it will immediately take you through the map. And here if you start navigating, it will also give you the complete path for the driver to assist him towards delivering it properly. All this happens real time. Particularly the decision making and the map update happens definitely in real time, which will help the driver to make the decisions immediately to deliver the boxes. Thank you.